Hey, welcome to the second module of From Zero to Bot. In this lesson, we'll take a look at the software architecture for our trading bot. Then we'll take a deep dive into the development of our first component. So we'll use this component to retrieve prices from the blockchain. So let's begin. All right, so let's get into the architecture of this whole thing. So I did not go into this in great detail in the introduction, but I just wanted to go over this so you understand what the core components of this bot are. So this will give you a very high level view of how we're going to architect this piece of software. And I'm going to show you component by component what we're going to build and give you a little description of each component. And then at the end of this whole thing, we'll go ahead and I'll show you how to tie everything together. So first things first, we start off with a client. And this could be anything. This could be a desktop application. So this is what the user sees, right? This could be a website. So if your software stack is you want to use JavaScript or whatever, you can use this as your front end. So that's what you call your user interface, basically. So you can write this in anything you want. In this course, I'm just going to be using pure Python, but you can do it however you want. If you're familiar with JavaScript, then you can definitely incorporate all these concepts in whatever language you please. You can write your client in this and an interface with Python code if you wish. That's a pretty good stack, actually. A lot of developers use that stack. They'll use some backend system like Django or Flask to do that, where they'll have a client where the client is written in JavaScript and it ties into Python code. So it's a pretty popular framework that people use. So don't worry about that if you don't know anything about it. I'm guiding you through the process. I'm going to teach you how to do the UI in Python anyway. So, but if you want to learn how to do it in JavaScript or whatever, you're free to do that as well. So you got your client. What is a client? Well, it allows the user to click buttons and do things and configure things. So obviously, this is your trading bot. So you're going to allow the user basically to make trades. So we need to build the components that allows the user to do this. So this client is going to tie into a lot of different components. Well, not too many, but there's some core components here. So the client is going to tie into this component called the market manager. I've already predefined this design, so I'm not going to explain to you my rationale behind it. Just understand that I've been developing software for over 20 years, and then this is just how generally you start building your software. These are the components I came up with. So I identify the core components that this software needs, and this is it. So here's the market manager. What does this do? Little description. It monitors market conditions. That's all. So what does that mean? Well, so when the client wants to get a price, so say you want to display a price to the user, you would utilize the market manager to do that. So the client code would make a call to the market manager and say, hey, I need the price of this token. If you're trading dog with hat, then the client would request the current price of dog with fat so that he can make an informed decision on that. So the client may also have some auto trading features. So the client may make a decision based on that price. I will get into that a little bit deeper in a second, but just know that this market manager manages tokens of interest for the client. So getting back into this, so we have our market manager that does that. We're going to have a trades manager, or I'll call it trading manager. So this is going to be the thing the client interfaces with to actually place trades. So that's one of its responsibilities is place trades, allow the user to place trades, manage those trades. Yeah, the management part has to do with your trading strategy, manage trades. All right. So this trading manager will manage your trades. Very simple. It can be used to do your buys and sells. So if you just want to manually do this, then you can use your trading manager to do that. If you want some things to auto trade, then you'd implement some sort of trading strategy into here. One line that you don't see is how these things get information from the blockchain. So that's the next piece here. you basically need some sort of API to talk to the blockchain, like I mentioned before. You either need a RPC node, and there's other APIs out there that allow you to talk to blockchain that we'll get into. But just know that there's going to be something in between there. Trading manager, in order to place trades, basically you need to talk to an RPC node to do that, to place a trade. That could be your API, your RPC, or it could be something else. And I'll get into that in a second. That is basically the architecture of our system. So just to sum it up, we have a client, we got a market manager, and we got a trading manager here and a blockchain manager. So, or we got a blockchain API right here. So these are the core components. You'll be building these things, and I'm going to show you how. And it's not that hard. You're going to have your own bot in no time. All right, so let's get into the architecture of the market manager. So we got our market manager right here. So major responsibility is that we use it to get price of a token. So the user is going to request, hey, get me this price of this token. This market manager will handle it. It needs help to do that. So it's going to utilize the blockchain API. So in this lesson, I'm going to only cover Raydium tokens. So Raydium tokens are pretty popular. You can start liquidity pools on Raydium. Everybody knows about Raydium. It's one of the most popular decentralized exchanges used. So there's other ones out there, but I'm just covering Raydium for now. In the bonus material, I'll go ahead and cover pump fund tokens as well. It also will need an API, but for now, I'm just building the foundation here. So later on, if you want to add an API for another decentralized exchange, you're welcome to do so. This will give you the building blocks for doing that, and it'll be easy to integrate that into this. For this, I suggest using something called a Raydium API. This will be used to get the price for the first time. And it's pretty simple. I'm going to show you the ropes on how to do that. You query the price and you get the price. There's other APIs out there, and I'm going to show you what they are. All right, one option is the crypto API from CoinGecko. It provides you a lot of functionality, but look at the price of it. So just to get some basic capability, you can see the comparisons here. One of the factors of buying into one of these things is do they rate limit you? Most of them will, so that's one thing you have to consider. You could buy one of these things and it could make your life easier if you just want to get the price of something, a token price. These APIs will help you, but there's limitations to it. For this CoinGecko one, you're paying a lot of money to use this thing. So I'm basically showing you how to do it for free. There's other ones, Bird Eye API. That one's also expensive. I think it's like $2.99 a month. So these things provide probably more capability than you need, but it's worth looking into if you're interested in using this. It's available, and it can make your life more simple. And you'll see in a second why. There is an easy way to program this, and there's a hard way to program this. All right, so going back to the diagram, let's go into how we're going to actually build this thing. So I'm going to teach you how to get the price the free way. So let's say the client wants to monitor a token. He's interested in a token called Popdang. He's going to make a request. He's going to put it in. He's going to use the client to make the request to go ahead and monitor this token. So this would be a different path now. Market manager will have to deal with that. It would say, okay, well, how do I get the price of that? Well, it could go the traditional path and use the Raydium API. However, this Raydium API is free, but it has limits, and there's no way to upgrade a plan or anything to get more out of this Raydium API. So once you reach the limit, calls per second, I don't know what the rate limit is, but once you reach that, it's going to shut you down. It's not going to let you make any more calls. So you got to use this thing sparingly. This thing is super useful for getting certain information off the liquidity pools for the Raydium tokens, but you got to use it sparingly. Like I said, you can't rely on it because if you want more rates, limits, and all that, you got to use those other APIs that I was talking about, CoinGecko and all that. You could pay for extra features and higher rate limits and things like that. This Raydium API is available to everyone and it's free. So at any point in time, it can kind of pull the plug on you. So let's just use it sparingly. We are going to use it in our method here, but but we got to employ, if we want to monitor a token, what we want to do basically is get the price, go ahead and query the price from the Raydium API the first time. So it's going to go down this traditional path where it's going to just grab the price. But what's different about this is when the user actually is interested in monitoring this token for whatever reason. It could be that he wants to monitor it until it reaches a certain point in price. Whatever it could be a strategy where he's trying to monitor the volume. So what we need to do is we need to kick off this thing called a monitor. So right now I'm just going to call it a token monitor. Basically, we'll just call it something generic. We'll kick off a token monitor, and we're going to make a request to monitor this token. Going to kick off that request to this token monitor, and this token monitor, what it's going to do is it's going to subscribe for updates to token price. So you don't have to understand this completely, but just understand that I'm employing this new method to get the price so that I don't have to call Raydium API 100 times a second. Basically, that's what I'm trying to avoid. So since this thing is rate limited, I'm using it sparingly. What I'm going to do is I'm going to follow an alternative path to getting the subsequent updates of this price. So subsequent updates can happen. I mean, you could get thousands of updates per minute. I mean, on some of these tokens. So calling Raydium API 1,000 times per minute probably won't fly. So I'm just letting you know that if you thought that, oh, you could just use Raydium API for that, you can't. You'll get throttled and you won't be able to do anything. So let's go ahead and dive into the code. I know you've been itching to get into some code. You're tired of these diagrams, right? So let's get into it. All right, so let's get started with Visual Studio Code. You don't know how to set this up, please watch my other video on this topic. I'll have a link at the bottom. Go ahead and open a new folder for this. Right now I have this module 2 set up right here. It's empty, so I'm doing this from scratch, guys. I'm doing it with you. So the first thing you're gonna do is you're gonna create a class, create a file called Market Manager. So this thing is going to be a class. So basically that component I drew for you, that's basically what a class is. A class provides the functionality of that component. It's basically something you can pass around and utilize within your program. So we're going to create a class. Good practice. Go ahead and comment what you got here. Put comments in. Manage token market activities. Basically what I reiterated, just so you understand what it is. Okay. And then go ahead and define the class. Just follow my lead. If you don't understand what I'm doing, it's okay. You're gonna pick this up pretty quickly as you do it. So just follow along. Manager. Okay. Threading. And in addition, if you bought the course, you have access to the source code right away. So if you just want to work with it like straight away, you're welcome to do that as well. So first line, we're setting up the class. Why did I set it up as a thread? Well, this market manager may need to be running in the background doing things. Just know that we need something called a thread to have it do that. It may need to be, it's going to be monitoring things, right? So we need the thread capability to do that. How do we do that? Well, we add in this, we basically make it, we add this threading inheritance to it. That's the simple way of explaining it. Just do that. It's complaining right now. It says, oh, threading is not defined. What you have to do is you go ahead and import the package for this threading, and I'll do that. Takes that away. And every line, every definition of a class needs a colon at the end. This is just the syntax, and anything under the class needs to be indented. That's just how you specify the contents of your class. So here's what I'm going to do: threading dot thread dot init. Okay. And this is why I like Visual Studio Code. It kind of completes things for you. So it kind of knows what this the contents of the thread are. So it gave me this init method. Basically, I wanted to initialize this thread. Okay. I made a little mistake here. So what I want to do is I want to define basically an initialization function for this class. This is how I do that. So self and no inputs just yet, but basically this is an initialization method, and this self indicator indicates that this is a class method basically. So you need to put this in here, this self, and you can put in additional inputs for this initialization method, and you'll see how this works later. Like these inputs matter for this class. If this is not making too much sense right now, don't worry about it. Just keep on working through it with me, and I promise you'll get it at the end. And I'm available to answer questions for you. Just put them in the comments. So you could put in inputs in here, but I'm not going to do that just yet. Right now I'm going to initialize. This is just default initialization of the thread, and that's it. I'm defining the initialization part. So basically what we want to do first is go ahead and define the get price method. So I'm going to define a get price method, and again, this is a class, so I'm going to include the self, and we call these things methods. You can call them functions, whatever you want. You know, like in algebra class where you solve for f of x, same thing here. It's like you have a name, this would be like f, and then you'd have the input x, and then in here you would do something with x plus 5, whatever. So that's it. It's really just functional. It's just you pass in, somebody will call this, so the client code or whatever will call this, and then they'll pass in their x, and then they'll get a return value out of it. So typically if you want to return, so that's your Python 101. That's programming 101 for you. It's not that hard. So anyway, going back, we want to get the price. We don't call this get price. So I apologize if you already know all this stuff. I'm trying to break this down so beginners can do this too. So for getting price, you want to go ahead and pass in token address. Okay, call it a token address. So what I'm going to do here is I'm going to define the type of this input. I want to call it a string. This is not required, but I like to do this because it allows me to it allows Visual Studio Code to pick up and assist me in the coding process, and you'll see in a little bit how it helps me. But anyway, you don't have to do this, but I do it. It defines this token address to be a string. A string is just it's just a bunch of text. That's all you need to know. So to get the price, what are we going to do? I'm going to create this variable called return price. So basically, I'm going to start it off as none. So it's pretty obvious, right? So this is what I'm going to return at the end. Like return, I'm going to return this to whoever calls this function. I'm going to return the price. Oh, remember to get your indents right, otherwise you're going to have a syntax error. Okay, so now you got this token info. I gotta create a token info, and I'm gonna put some placeholder code here. It will not compile, it will not work yet, but I'm going to basically, let me just write a comment here actually. So what I need is to get some information about the token, and I'm just gonna make a comment here. Get token information. Don't know how to do that yet. Okay, don't worry about it. But that's a step I need to take there. Get token information, and basically what that comes down to is getting the information from the API. So what we're going to do is we're gonna get the liquidity pool information. I'm gonna call it liquid LP data. Okay. We get LP data, and I'm going to go ahead and call something called the tokens API for this. We have not written this yet, but this is basically your blockchain API component that I called out. Note that I might not specifically name it the same as I do on my diagrams. So that might change it a little bit. So just know that this is the blockchain API part. So I'm gonna have a method here called get AMM. Oh, this is just what I'm calling it. You can call it whatever you want. Pool data and token address. That's what I get. All right, or I'm sorry, I'm passing that in there. And if we get good LP data, if the data is good, if we get a good return off that, if it's basically you're checking if it's not none, right? So this thing is designed to pass back this data for me that I need to get the price. So at the LP data, go ahead and return, or go ahead and initialize rep price. Oh, by the way, I like to name things. At least in Python, the convention is to underscore the words. So rep price. I forget what it's called, but there's a name for it. But anyway, you name things in this manner. In Python, it's just convention. In other languages, it might be different. Some other languages use camel case. They don't use underscores. So I'm gonna go ahead and initialize this rep price if if LP data worked out. Then I'm going to go ahead and initialize it. I'm going to initialize it to LP data. And at the end, I'm just going to return the price, the rep price, right? Going back, I don't really need this. I guess I could just return LP data in this situation. Return LP data instead of doing all that. So I'll just simplify it. So basically that's it. That's my getting the price. I'm using the blockchain API to get the AMM token pool data, and I'm returning the LP data. Oh, LP data dot price actually, because this LP data is going to contain more information, right? And you'll see in a second why. So tokens API does not exist yet. So what we have to do is let's go ahead and work on that. Let's work on a class, or it's not a class, it's just a set of functions that we're going to need. I would call this more of a utility than anything. So I created a new class called tokens API. Now I'm going to define the get AMM token pool data. And then I'm going to go ahead and pass in the address. Okay. So I'm basically creating that function that I was calling in Market Manager, right? So I'm going to declare that as a string. Again, just like to do that. Also the return value, I like to tell it what I'm going to return in the tokens API. So I'm going to return something called token info. What is token info? I'm going to show you in a second. So basically the job of this thing, let me comment it, is to retrieve a token's liquidity pool data using the Raydium version 3 API. That's the most current version, right? And what it's going to do is it's going to make an API request, Ray URI. It's going to make a request. Okay, to this link right here. It's just an HTTPS. The HTTPS site basically that allows you to get certain information from the Raydium pools. I'm going to have something in addition to that. I'm going to go ahead and create this a URI for the market ID. I'm going to explain a little bit to you what this means in a second. I'm going to go back to the diagrams. But basically what I'm doing is I want to query. I want to make a query to the Raydium API for this this token information. So how do I know all this stuff? I'm going to show you in a second how I know what this URI, how to make this URI path. So basically what I'm doing is I'm just creating a string. So I'm appending this HTTPS with this information here. So just understand that I'm just concatenating this string together to make one big string. So, and what I want to do is I want to go ahead and throw in the token address that the user passed in, or the caller passed in. And I'm not going to type all this. Just going to cut and paste this. I got this actually from my browser. And I'll show you in a second how I got this. All right. So this is the query. Basically, this is the query that you need to make to query the Raydium API so that you can get back information about this token, including the price. So let me go ahead and show you what I'm talking about here, what it's actually doing here. All right, so you probably know what this is. It's a deck screener. So I just chose this token. It seems like a popular one right now, Mooding. So I'm going to grab the token address. That's this one right here. You go down here, and this middle one is the token address. Okay. Then I'm going to open up this. This is the Raydium API version 3. What this allows you to do, it allows you to test the API calls right on this little website right here. So what I'm going to do is I'm going to go down here, find pools. And I'm going to I need to get the pull info by token mint. So what you need to do is you need to pass in, well, I gotta click try it out. Pass in the mint. Mint is another term for token address, basically. All right, so pool type, I'm just gonna choose a standard pool type. We're dealing with Raydium standard pools here. We're not dealing with anything else, but it's the most popular kind. All right, page size, we'll just make it page size 1, and that's all you got to do. Okay, page size is just call that 1, and that's it. Execute, and basically, yeah, you get something out of it. It prints out your result here. So there's a lot of good information in here. Oh, look at that. We got price. So highlighting that, we can actually just go on our way, extract the price out of this. This body right here, response body, it's in a format called JSON. So this is the format. I think I explained it in the introduction. It's used to pass around data between components. It's usually used for web development. You can use it pretty much for anything, for passing data around from software application to software application, from service to service, etc. So I'm going to show you how to do this right now, is how to make this call to get this information so you can get the price. You might want to note some other things that are in here that are pretty useful, that might be useful for you. For instance, there's burn percent in here. You could see how much of the liquidity pool tokens are burnt. If you've been in the crypto or the meme coin trading scene for a while, you understand that you usually want to see that 100% of the LP tokens have been burnt. That kind of makes the trades makes the token a little safer. So I'm not here to talk about all that. You guys can do your own research on all that stuff, but I'm just showing you how to program the bot. So getting more into this, let's dive into back into the code so I can show you how to do this, how to extract the price from here. I'm going to come back to this in a second, but let's just go back to the code. So I already created the request. You could actually cut and paste this into your browser, this whole request, this HTTP call. Let me just show you really quick. So this Raydium API tryout site, it kind of makes everything pretty for you. But you can actually just cut and paste this whole thing, this HTTP line right here. You can paste it into your browser, and then you get the JSON data, right? And then your program would go in here and try to extract the information that you need. Okay. So that's basically what I'm doing. I'm trying to create this URI, basically this URI. Mint1 equals this thing right here. This is your contract address. So that's pretty much what I'm trying to do. I'm making this URI up in the code, and I'm adding our token address. I'm swapping it in with what I want here. So that's it. Let's go back. So I already created the URI here. So now what we need to do is we need to make the API call. Okay. So data in here, the data we're going to initialize that to making the request. So I'm going to make a call to a function I haven't created yet, but I'm going to pass in this market ID. Oh, I misspelled this. Market ID. Yeah. Okay, I'm gonna pass in this market ID URI. So let's say I get good data out of this. So what I'm going to do is I'm going to check the length. What I expect to get out of this is an array. If you don't know what an array is, it's just a collection of information. It goes from 0 to the number of elements inside that collection, basically. So it's just a way to store information in sequence, basically. So, like I said, if that doesn't make sense, it's okay. Just you'll get it. Just keep at it. So I'm checking the length of this data array, and if it's greater than 0, that's a good thing. So I'm going to try to. Okay, what I'm doing here, don't worry about what it is yet, but I'll explain it in a second. So I'm going to try to do something here. Basically, I'm telling the Python interpreter, to try this. It's something that could fail on me, so that's why I put this try statement here, is what they call it. So what I'm going to do is I'm going to go ahead and try to create a new token info. Remember this thing right here that I put over here? That's what I want to return out of this thing. So I want to create a data structure that contains basically a package of information about this token. So that's what I'm trying to do here. So, oops, I misspelled. So token info, and what I want to do is I want to go ahead and pass in the token address into this token info. So I'm creating a new token info, and let's stop there for a second. So I want to define this token info. You can define it in this class right here. So what I'm going to do is I'm going to define this class called token info, and this will get rid of those squiggly lines for the token info definitions. So I'm going to create a class called token info. Doesn't need to inherit anything. Remember, I did the threading thing on the market manager. I don't need to do that here. This is just a data structure, guys. So going into token info, what it's going to need is it's going to need an initialization method or function. So init, oops, kind of filled everything out for me, which is nice. Visual Studio Code is set up to do that. But I do need, actually I don't want that. What I do need is an input, because I want to pass in the token address to this token info so I can identify it so what I'll do, since this is a class, I need to basically create the variables. I call these variables that belong to this class. So like I said, you can instantiate these classes, and you basically have these objects that you can pass around between your components, which is really, really handy. So you got your token address. All right, that belongs to this. What I'm going to do is I'm going to go ahead and assign it to the input. And notice that the names are duplicated. They don't have to be. I just do it, out of convenience. I could have named that 2 and it would have been fine. But anyway, I'm just naming it that. So by declaring this as self, I'm saying that this is the token address that belongs to this class instantiation. That's all. Hopefully that makes sense. And what else? I can put in anything that I can think of right now. So we might modify this more later, but how about price? Let's store price in there. How about that? We'll go ahead and initialize it to 0 because we don't know yet what the price is. And we're gonna need some more information in here. I'll show you in a second what we'll need. But for starters, that's what it is. Okay. And I just declared it here. You can declare this in its own class. Probably it would be more proper to do that. Declare this in its own class. But since this is something that is created by this API, then maybe it's best just to leave it in here. So it's okay. So let's see. So let me see. I'm going to one other thing is this get request function. Let's just knock these down one by one because I can't. I will not be able to compile this until I get these implemented. So this is the way I like to code. I like to kind of like do the skeleton framework. It may not compile, but then it gives me something to work with, and it allows for pretty smooth development. So I'm going to create a function called get request. I'm gonna actually, yeah. What you have to do is you have to be, if I want to define it here, I'm gonna go ahead and put it with no indent. I'm gonna start it off with def, and then I'm gonna call this get request. And I'm gonna request URI. I'm gonna go ahead and call it the input request URI. What is that? It's just a string. It's just text. The HTTP name. Why I'm creating this is because I might have other API calls I need to make. So this allows me to just kind of generalize things so I can reuse this part of the code. That's all. You don't really have to do this. This is just good programming practice doing this. So I'm just gonna make a comment, or you guys can make comments in this. I'm just gonna kind of race through this. The code that's on the repository is well commented. I'm just gonna say, but I'm trying to go through this a bit more quickly, so I won't comment everything like the final product. So what I'm going to do is I'm gonna call something. This would be a utility class or utility package that I use to go ahead and send the HTTP request in. It's really called a get command. So it's just something, if you want to do your own research on that, on what HTTP get commands are, you can do that. But just know that this will send the HTTP request through, and it's going to get a response back. Basically, it's in the browser. Remember, I had the browser up. Did I close it? May have. Just 1 second. Did I close it? No, never mind. All right, so just know that that's basically what it's doing. It's basically just executing this. That's it. So notice this has squiggly lines. That means that it doesn't know what this request thing is. So what we have to do again is we have to import requests, and it gets rid of the squiggly lines. Yay. All right. So now we're good. We got to finish up this get request. So I'm going to go ahead and implement the rest of it. And I'm going to go ahead and check to see if the response was successful. So what you can do is you can check this thing called the status code, check to see if it's 200. If you look up get requests, if you get a response code of 200, that means everything went through fine. If you get something, I think it's 400 and above, then that means something bad happened and it wasn't able to fulfill your request. It can do that sometimes. The server might be down. It might not be able to handle the load of all the requests it's getting. So yeah, you may get some failed requests there. It's up to you on what you want to do with that. You may want to retry, or you may want to use another API address. So yeah, you're a little bit dependent on these APIs. Like if they're not, the servers are down and stuff, then your software might go down too. So that's just something to consider. It's good to have some backups. In the bonus material, I'm going to show you some more advanced methods to save yourself from that type of headache. But know that this Raydium stuff is widely used, so it's pretty stable. I haven't had any issues with it since I've started using it. So just know it's pretty reliable, but anything can happen. But just be aware of that. So I'm gonna return. So if it did, I skipped that part. I just wrote that. I didn't talk about it. So if it is good, if it did go through, so I'm gonna return the response, but I want to return it in the JSON format. So basically, what I showed you before, I want to return this. This is your JSON that has all the information you need. And if not, just return none. Basically just saying, hey, I didn't get anything, right? All right, so going back here, now I define my get request, and now this doesn't have a squiggly line under it. That means it's good. I'm going back here. If the length of the data is greater than 0, that means I got something, right? So in the JSON data, you go back here. Basically, this bracket here indicates that this is your data. Well, you have this data, right? This is just how this data is formatted. Well, actually, I'm sorry. It starts out with data. It's a little redundant. You get your data, and then you have basically under here you have all the data that belongs to this request, or that belongs to this response body. So under here you have an array. If it starts with a bracket, that means it's an array. So just know that that's what I'm checking for. I'm checking to see if that length of array is at least 1. So if it's greater than 0, then I'm going to go ahead and I'm going to go ahead and try to do something with that. So what I'm going to do first is create a token info. So remember we created that data structure. So here's how, this is what I'm going to do for you. I'm going to tell you right now that I need 2 pieces of information from this JSON, okay? And I'm going to show you how to extract it. Looking back at this, let's search through this. So this is basically what I'm going to be getting, right? So what I need is, I need this, I need price, okay? The other thing I need is, I need the other thing I need is something called the market ID. So don't don't get confused. I'm going to explain to you why you need this, but you need let's just say you need those pieces of information. That's it right now. There's other things in here you might find interesting, but just be aware that you just need that right now. So let's add something to our token info. I just said that you need something called market ID. It's a string. It's kind of like a contract address, sort of, but it's part of the open books. Is it called open books? It's part of the open books framework that Raydium tokens belong to. So let's just say we need that right now, and I'm going to basically parse that information from the JSON that we just got, right? We got our token info, and I want to initialize my market ID, and I'm going to notice how Visual Studio Code helps me. Like when I do dot, it knows already. Oh, market info has this information, so very useful. Make sure you take advantage of that. If you're just using a text editor, good luck. That's just these features may just make things easier to code. All right. So data. All right. So we need to do is this data. So, and then under that is another data, right? It's a lot of datas, right? It's just nested in there. But this is what we got to do. And then you got your ID. Okay. And then the next thing we want to initialize is the price. Oops. Token info dot price. And we got our data. Same thing. I'm going to just cut and paste this. It's a lot. It's one thing about JSON formats, especially with Solana JSON formats. It seems like there's a lot of redundancy. So we want to check the first index, array index. Remember, arrays start at 0, so that's why I say 0 there. And we already guaranteed that we have at least one element in that array, so that's why I put you're guaranteed to get that element. And we want to get the price. So if all goes well, this should initialize. Basically, I will go ahead and extract those pieces of information. I recommend that you test this. Like at this point, well, let's make it compilable first. But I would stop actually at this point. So we need to, yeah, basically we need to make this compilable. What I need to do is I need to put this statement here for the exception. So if we get any exceptions, right now I'm going to make this very general. For now, don't worry about it. Typically, you want to be very specific on what type of exceptions you're catching. That's what an exception is if something goes wrong here. So say I'm trying to extract market ID and then this doesn't exist, or there's something wrong with the format, or maybe it's not even JSON for some reason. This thing will throw an error, and what that'll basically do is make your application crash, and that's no good, right? So what this allows you to do is gracefully handle the exceptions. So you could get a multitude of exceptions here. So it's good to be very specific on what type of exceptions you catch so you can handle them gracefully. You may want to do certain things like retry the request maybe, or modify the request in some way. But right now, let's just assume everything's good. We'll go ahead and print it out though. Like if we do get an exception, we would like to know that, hey, something happened. I'll just print out in the exception. I'm putting it into this variable called E. So what we can do is just print out E. So the statement saying accept the exception as E, go ahead and print out E. Okay. Okay, now this is compilable. You can actually press play here. If you got your environment set up, you could just press play. Visual Studio Code knows that this is a Python app. I could do a separate video of how to test this, but I recommend testing this and walking through the code at a minimum, just to make sure that things look right. Really quick, I'll show you how you can test this. Just really quick. I won't cover this again because this is not what this course is about. It's not about, it can be about teaching you Python, but I'm not going to go into depth on how to do test cases. You can read that stuff up on your own. There's a lot of free information on it, and I can provide links to some of that. But really quick, I'll just show you. I'll just demonstrate it really quick that it works. So down here, you can actually execute, start executing this code. What I'm going to do is I'm going to make a call to get AMM token pool data. And let me pull up the token Mudang. Let's see if it's active. It's got some activity within the last 5 minutes, 40 transactions. So it's relatively active, especially right now at this time. So what I'm gonna do is I'm going to try to see what happens when I do this. If I implemented this correctly, then I should be getting this information out of this. Let me just add in a return here. This is just a statement saying that you're exiting this function. Sometimes you return a value. It could be a value to return, or you can return nothing. You don't really, if you're returning nothing, you don't need to put this here, but I'm doing it in this case so that I can put a breakpoint. So this is basically one-on-one on debugging. So I want to test to see what happens when I start the function. I'm going to go ahead and press play here. Hopefully all goes well. Okay. So it's starting to execute it. You see these components right here? These are debugging components. It allows me to walk down here. So if I made any mistakes, I'll see it right away. So what it's going to do is make the request here. And it's going to get the data. Right? It got something. I can't really make sense of it right now. But it looks like it got something, right? You could look in here and try to dig it up, but it's going to go through this first condition here. It's going to check the length of the data. Oh, by the way, this is a very useful feature if you want to watch this. Like if you want to look at it in greater depth, you can go ahead and right click and select to add to watch, and it'll show up on your left side of the screen here. Or however you have your windows configured, it'll show up somewhere. So you got your data here. See, this is the JSON right here that it picked up. So it's got the information in here. See, price. Somewhere up here is probably the market ID. Somewhere in here. Market ID is here. See, it's all there. Yeah, so it looks pretty good. It looks like our code is working. So it's going to go here. I'm going to create a new token info. you can actually hover over this token info just to see what it contains. And right now, price, yeah, it's initialized to this. Market ID has nothing. So I'm going to initialize market ID right now. So this is where the rubber meets the road. So if I got that right, then it should initialize market ID. Boom. All right. Market ID looks initialized. That's what the market ID is. You can, if you don't, if you want to validate it, you can go back to this on your browser and then validate. Oh, yeah, market ID looks like that, right? So there's that. I think I had another token entered in on this one, but anyway. So, and then the price. I'm getting the price. Boom. So now I have a token info that's fully initialized. Now I have a price of the token. All right, just want to clarify one thing. The market ID that I'm trying to get is this right here. It's not the one down here. This is something else. This is the open book market ID. So just want to make that clear. But that's what I'm doing in the code, and that's what I'm getting. I did notice something though. It's a little bit alarming. I've never seen this before. So let me run this through really quick. I'll show you. I'll show you how to fix it. But there's one issue. So I'm running through this and I'm getting the token info. I'm getting the ID, which is fine. That's what it is. The price of the token though is it's supposed to be in Sol and it's supposed to be unscaled. 629 Sol per token? I don't think so. So if you look at the DEX screener, it's a Mudang, right? It's not. It's 0.001577 Sol. Okay. So that tells me that there's something going on with this Raydium API. It's not providing the right price. Usually, this is the first time I've seen it not provide the right price, but that's okay. It's okay because this next part I teach you how to actually extract a very accurate price, and you don't have to rely on the price that's provided to you by the Raydium API. So let's get into that. All right, so here's the way it works with a Raydium liquidity pool, a, a liquidity pool made for a Raydium token. So what happens is when somebody creates an LP, just like the LP is short for liquidity pool. What happens is Raydium, there's a program involved. It's the Raydium program, Solana program. It invokes and it'll initialize the pools. So there's one pool, or they call it a vault. So there's the token vault. I would call it token reserves. So the creator of this token pool needs to allocate some token reserves into this liquidity pool. And then I call this the token reserves vault. And so say they allocate 900,000 tokens into this thing. They can do that. That would get stored in the vault. So there's a CA for this. There's a contract address for this. And then there's a Solana reserves vault that gets created here. And there's also CA for that. If you know these two things, you know the contract addresses for these two things, you can actually calculate the price on your own. You don't need Raydium API or anything like that. So this applies to standard pools. standard AMM pools. So automated market maker pools created by Raydium. So this encompasses most of the tokens that get created. We'll use this sort of method. So anyway, so if you started it out with 10 Sol, then that would be the reserve. In the reserve, and then in the vault would be 900,000 tokens. Okay. How do you get the price? Well, it's pretty simple. Just take 10 Sol, divide that by 900,000. That's it. And then you get price per token by doing that. So all you need really is this. Okay. All right, going back into the code. So let's just say everything is fine. Whatever. We'll take that as the price, even though it's incorrect in that case. That's okay, because we're gonna correct it in a second. All right. So the next thing that we want to do is we want to go ahead and get we want to get more info about this pool. Pool info URI. We're gonna call this. Actually, I'm going to start this here underneath here in the try catch or the try accept. Okay. So we're going to use Ray AP URI. I'm going to create another URI, okay? And just follow my lead here. Key IDs equals, and then we're going to add in, what are we going to add in? Our market ID. So this should be my URI. So basically what I'm doing here is taking this market ID, whatever it is. So let me go back to my thing here. ID was this, right? All right, so all you have to do is grab this ID and go ahead and copy it into, go into the pool section of this Raydium API website. Allows you to test it. Go into pools/key/IDs. Remember, this is the URI we created. So you want to cut and paste that ID in here. Yeah. Let me click try it out. Go ahead and execute. All right, so now we should have the information we need, and we do. So first of all, you see the mint A is defined here as wrap sol. Mint B is Mudeng. That's important. Over here, the vault information is declared. A is this address, B is this address. So if you want to double check this, you can go into Sol Scan. Go into Sol Scan, and you can actually see. I'm going to type this in. This would be reserve A. And this actually shows the wrap sol amount in that reserve. And going back to this, B should be the token reserve for the actual token that you're interested in. And it is, it's Mudeng, right? It says that there's 8,579,410 tokens in there. So there you go. All right, going back to the code. So I'm going to continue here. So what we want to do is we want to make another GET request. And I'm reusing data. We don't need, the last data was already parsed, so I'm just reusing that variable. Okay. And I'm going to go ahead and pass in this new URI so that we can get what I just showed you. I'm going to go ahead and check the length of it, just make sure I have something in there. I want to make sure that the length of the data, same thing I was doing before, is greater than 0. And I want to go ahead and initialize token info. I want to go ahead and I got something called Sol Vault address. I just added this before. I think I didn't show you guys this, but I added these variables into the token info class. So I need the sol vault address, and then I need the token vault address. So I added those. So what I want to do is I want to just parse that JSON information. I'm just going to go ahead and it's going to be in data, and under that it's going to be data again, and then it's an array. So the index 0 there's just one element in that array. Then I'm going to type in vault. So I want to get that vault info and an A. So this would be your vault, your sol address, sol vault address. A would be it. That was just how it was defined. And your next thing would be your token info, token address equals the data. Same thing. I'm just going to cut and paste this. This would be B. Your token address would be B. And it's always going to be in this order. So it's going to be vault A is going to be your sol, either sol or wrap sol. And then the second one would be B, would be your token address. So what we want to do now is, if this went well, go ahead and, well, we'll just assume it went well, and we'll just return our token info. So now we should have a filled out token info. So everything in this class should be filled out. And we can go ahead and test that. We'll do the preliminary test. I'm not going to do this very often, but I'm just kind of showing you how you can unit test these things. It's a good idea to do that, but that's not what this course is about. If you want me to teach that, I can create a separate course just for that. I could probably arrange that. All right, so let's see. Let me go and grab the contract address for the previous token I was looking at. I think it was Mooding. Okay, I'm going to copy the contract address, paste that into here, and I'm going to go ahead and hit debug. Go into this corner here and then hit debug. Oh, let me set a breakpoint to this point. We already know this stuff works, right? So I'm just going to set a breakpoint here, and I'm going to hit the debugger here, and boom, I got the data. So this request went through. It looks like I have some data in there. So if you dig down in there, you can find all that information we're looking for. So here's the vault information, A, B, right? So if I parsed it correctly, I should get sol vault address. I hover over here and I see that, oh, okay, that looks like the right sol vault address. I can verify it by going back to the API site, looking myself just to make sure. It's a good idea to validate this stuff just to make sure you're coding it correctly. And then you get your token address. Actually, I made a little mistake here. Not token address. It's actually the token vault address. Sorry about that. So let me go ahead and retry that. Right, and then there we go. We got our token vault address in there. And that should be it. We should have a filled out token info. It's got all the information we need. So it's got our market ID, it's got our price, it's got our vault address. So anytime we need to pull price from the vaults, we can use the CA to pull that. And I'm going to show you that a little bit later, how to do that. This price here is pulled straight from the Raydium API. Look how it doesn't look right, 704. It's actually correct. It's pulling in the right price, but that price that it's pulling is actually the number of tokens per sol. So realize that it's the number of tokens per sol. What we are going to have to do, I need to modify this to actually divide, if we want to put this in terms of sol. So if you go to deck screener, notice how the price is 0.001426 Sol. Well, let's go ahead and fix this really quick. Yeah, what you can do alternatively, like I mentioned before, is just pull the information from the vaults and then calculate it yourself. But since we're already extracting price from API, why do it again if we don't need to? But in the future, I'm going to show you how to pull that information from the vaults so you can calculate it yourself, because you're going to need to in a second, and I'll tell you why. Actually, I think I already told you why. It's because you can't be calling the Raydium API too much, otherwise they're going to shut you down and deny your request, and you don't want that. But in this case right here, we're only calling it once, so it's fine. Right. So let's take that price, since it's too big of a number. Let's get that token price. Let's get it right. So in the past, I've seen it return the correct price. I'm not sure why it's returning the tokens per sol, but in this case, let's just say that price is just a large number. Let's just do this for now. Typically, prices of tokens don't go above $1. So I'm just gonna put a $2 here, right? So I need to confirm first that it's always going to give you that in the give it to you in those terms. But for now, let's just do it. So let's see. Let's take our price and we'll go ahead and say price equals the current price divided by the number of tokens, basically. So I'm sorry, it's 1 divided by the token price, token and float up price. So the price they're giving you here is the actual number of tokens you can buy with 1 sol. So I'm taking 1 sol and I'm dividing it by the number of tokens it gives you. If this is confusing, let me know. It's just that that's the format they're giving you price in. So if we go ahead and run a debug again, you can see that. Let me go and stop. I'm going to rerun it. Right. It looks like it got there. And what is the price? 704. If we do that division, see what happens. We got .0014. Is that about right? If you go into Mudang, yep, it is. So 0.0014. So now we got the right price here. So in terms of sol. So just FYI, if that happens to you, go ahead and make sure that this price is converted correctly. So it really doesn't matter in the bigger scheme of things in your bot, because really after this, we're going to be calculating the price ourselves using the vault. So really this price is nice to have, but if it's an actively traded token, the next updates to the price are going to be calculated from the vaults. So let's get into the next part. All right, let's go back to our market manager. So notice I was calling the method that didn't exist yet on the tokens API. So notice how we got squiggly lines under this tokens API. Well, let's go ahead and we need to import it. So what we're going to do here is I'm going to put this in the top here, from tokens API import actually never mind. Okay, so what we want is we want the token info. Okay, import token info. We want that, and also we want to import the functions in tokens API. So this is a little confusing. No, just follow my lead here. Import tokens API as tokens. We're gonna call this tokens API. Okay. We'll just use the same name here so it's not that confusing here. If I change this to tokens API, it should get rid of the squiggly lines. So there we go. So now we got a completely valid request here. So what I want to do is I want to pull LP data, and then what I'm doing is returning the price in that token info that gets returned. So that's it. So that's simple. So if the client requests to get the price of a token that we're not monitoring, it would just do this, and that would be completely fine. So the second step here is, okay, so what if the client wants to monitor a token? So why would the user want to just call this? Well, maybe they have a display. Maybe you got a display in your bot that you just want to have a sort of like deck screener look, and you want to just request a price every now and then, just to update your UI. You want something like this, maybe. You could build this if you wanted to, and you can utilize get price without having to monitor the token. So let's say you're just looking at one token at a time, then this would kind of make sense, just to keep on calling this over and over and over. But in our bot, we're gonna have auto trades and stuff like that. So, but we might be monitoring multiple tokens. So we need a way to actually monitor the token and keep that price updated. How do we do that? Well, we'll go ahead and create a monitor token method here. And I'll go ahead and pass in same thing, token address. Let me just cut and paste that, save time. Right. And then we're going to, what are we going to do? This thing is not going to return anything. What it's going to do is it's going to utilize the, remember I drew a picture of it, of the monitor, the Raydium monitor. So what we're going to do is we're going to do a call to self. It doesn't exist yet, but I'm going to create it in a second. Like I said, I like to do this to kind of skeleton things out. How am I going to build this? First of all, I designed this out first, so I know what classes I need to invoke, or what functions I need to invoke. So that's why it's pretty fluid. So monitor token, I'm going to go call monitor token, and I'm going to go in and pass in its token address. Okay, so I should have this thing called Ray Pool Monitor, and I'm gonna go and just pass it in. So what is Ray Pool Monitor? Well, we're gonna create that in a second here. So let me go ahead and put this in the constructor. That's what they call this. If I didn't mention that, this init thing is a constructor for this market manager class. Okay. If you need more of a 101 on how to program in Python, I can put some links down for you so you can get more familiar with it. I'm trying to go step by step and teach you what each of these things do, or each of these things does. But if you need a more thorough walkthrough tutorial on Python, there's really good Python tutorials out there if you're interested. But I would say the best way to learn, honestly, is to just do it. Just start, even if you don't understand exactly what's going on, you're going to start to pick up on this. I promise you, if you do it and practice it enough. So worst case scenario, you end up with a bot that's exactly what I just coded, and that's completely fine. And maybe that's all you want. All right, so I'm going to go ahead and initialize this. So what is this going to be? What I'm going to call it Raydium tokens monitor. And what I'm gonna do is I need an input to this. I'm not gonna fill this out just yet. Let's go ahead and start creating our monitor though, so we can define what we actually need to do this. So the design behind this is this Raydium tokens monitor is going to monitor the vaults for changes. It's going to monitor. Remember we pulled the vault information? Well, this monitor is going to it's going to be event driven. It's going to listen to changes to those vaults. And when changes to those vaults occurs, it's going to keep that price updated. And we're going to go and get into that. So let's go ahead and implement that. Raydium, we're going to create a new class called Raydium tokens monitor. .py. Okay, there it is. And let's see. So what we need to do is, first of all, we need to define a class of Raydium tokens monitor. So this thing is going to be doing stuff in the background, so we do need threading. So I'm going to put this in. You're familiar with this. We had this in the market manager code. We got squiggly lines, so of course you got to import threading. Import threading. There we go. Gets rid of that. And we need that same line from market manager. Threading dot init. Oh, I'm sorry. I have to define the init method first. This would be our constructor. Init. So, and we need something in here. We need an input, but I'm not there yet. So there we go. You indent, and then we put in the threading thing in there. The same thing that's in market manager. So off the top of my head, what we need here is we need a way to track the token infos. We want to go ahead and store the token info information so that when the caller, in this case it's market manager, needs it, you can just pull it up from memory. So we're gonna have something called it's called a dictionary. So I'm gonna show you in a second what it is. I'll have to probably draw a picture for you, but we're gonna store our token infos basically. And the other thing is we're going to keep a record of which tokens are actually updated as well. Updated tokens. So basically I'm going to keep a list or a set of token addresses that have just been updated. Okay. And then I'm going to, I need some other things in here, but I'm not going to define them just yet until I get to that part. So that's our constructor. The next thing we want to do is, let's go ahead and define that monitor token. Remember, it was that method we were calling for market manager. So what's going to be passed in, we go back to market manager. We're going to go ahead and pass in token address. So let me go ahead and just paste that in there. Token address, it's a string. Doesn't change. Is it going to return anything? Nah, not. So I need to get into the theory of what this has to do. So I'm going to draw again. But basically, well, let me pull up the whiteboard here for you. All right, going back to the whiteboard here. So we have our token monitor here. Okay. Remember, we named it Raydium. This one isn't named Raydium tokens monitor. But anyway, this diagram is just more general. It's going to have to access the RPC node. RPC node. You can look at this as another blockchain API in a sense. It's just, we remember we dealt with the Raydium API. Well, this is just another kind of another version of it, Solana RPC node. So basically, we're going to make requests to the Solana RPC node. What we want to do here, this token monitor needs to make a subscription to Vault updates. And so this is an event-driven thing. This is the RPC node provides this ability, and then we're going to have to use something called WebSockets to do this. So this RPC node will go ahead and on update of the vault that we're interested in, it's going to go ahead and update our token monitor. It's going to keep us updated. So what we need to do first is we need to subscribe, send a subscribe request to this RPC node, and then on the updates, we're going to get notified by the RPC node that there have been changes to the vault. And let's get into that. All right, so going back to the code, we're going to go ahead and implement the monitor_token method. And the first thing we want to do is we want to go ahead and check to see if we have a WebSocket initialized. If it is, then we'll go ahead and monitor the token. If not, then we'll just kick out of this method. There's nothing we can do. We can't monitor the token without the WebSocket being initialized. So that's handled. That'll be handled elsewhere, and you'll see in a second. But let's go ahead and start the implementation for this. So if we do have a WebSocket, what do? Well, we check to see if we're already subscribed, if it's in our token info's dictionary. That means that we don't really have to do anything. All we have to do is get it out of our token info. We just retrieve the token info from our dictionary. So this would indicate that possibly this request was already sent, but in the case that we have to reconnect to the WebSocket, we would have to resend the request to get that data coming in through again. We would have to resubscribe. So that's why I'm doing this. So even if it is in our dictionary already, it may have already been initialized, but maybe the WebSocket failed at some point. Sometimes that happens. So you have to reconnect to the WebSocket, and we'll have to send our subscription request through. And you'll see in a second where I use this. So it was just something I had to consider based on that, because WebSockets do fail from time to time. Sometimes they time out. There's certain things that happen there. So if it's in our dictionary, we'll go ahead and initialize this local variable token info, and we'll use that later. If it's not in our dictionary, that means it's a new token that we're monitoring. So we'll go ahead and utilize the same API. Actually, let me go to Market Manager. We're going to do this. See, remember we allocated LP_data to tokens API.get AMM token pool data. So I'm going to reuse that. So that's basically what we need to do, exactly what we need to do to get that token info. So if we successfully got some token info, we're going to initialize our dictionary. So this is where the entry in our dictionary gets put for this token. So this is how you set dictionary item. This is your key. Your token address is your key. This is how you access your dictionary entry for token info. And what are we going to store in the dictionary? Well, we're going to store our token info in there so we can access it later. So if we don't get a token info, let's say Raydium API couldn't find anything, or the RPC request failed, or something like that. We'll go ahead and just return something. You might want to build something a little more robust than this, but I'm just trying to do this quickly. But you may want to add in an error or throw an error to the client so that they know that this monitoring this token failed for whatever reason, and they can take whatever action they need to. Or you can have some automated process take action. One action would be maybe retry the request. Another option would be write some code to utilize the right API for getting this token. It might be on a pump fund, something like that. All right. So let's go ahead and make a request. We're going to make a subscription request. And I'm going to use a function that hasn't been created yet. Create sub request. And I want to go ahead and pass in the token info dot vault address for the token vault address, basically. So when there's changes to the vaults, that means somebody did a buy or sell. So you don't have to listen to both vaults. Remember, there's a Sol one too. You don't have to listen to both of them, because when one changes, the other will change as well. So it's just the change of tides there. So when somebody sells their token, they get some Sol, and then that gets taken out of the Sol vault, and then their tokens get put into the vault address. And when they buy, their tokens get pulled from the vault address and sent to them, and then their Sol gets put into the Sol vault address. That's just how it works. There might be some discrepancies there with the Sol, with the Sol. That some of that Sol may be put into other addresses, but I'm not going to get into the weeds of that. All right, so let me talk about the sub request. Let me just explain to you what it is. So going to the Solana docs on the just on your Google search, here's the URL for that. You can search for Solana API, basically Solana RPC methods. That'll work. And go down to the Solana docs. You'll get here. You'll see all the HTTP methods here. And these are all things that you can use to access the blockchain. And we might be using this a little bit later, but for now, we're just going down here, WebSocket methods. This is what we care about. So this is going to allow you to subscribe to changes to this account. So we want to look at account subscribe, and this basically tells you the inputs that you need to provide this to subscribe, do this account subscribe. So we need to make this, basically, this is the JSON, and it's all filled out for you. Basically, you just have to cut and paste this, really, and then you need to fill this out with your own CA. So this would be we would put in the vault, the token vault address in here. That's the idea. So I'm going to go ahead and create a function for that. So better yet, let me go ahead and create a new class that will contain this function, because it really doesn't belong here. This is a tokens monitor, but I was a little sneaky and I created a new class called Solana RPC API, and I'm using this to store information about this about our Solana RPC. Basically, this is meant to be a mirror to the functions that are provided by the Solana RPC. So as we go, I will be developing some of these methods here. It'll basically be a mirror, but I'll only implement things that we really need in our bot. So there's some of these HTTP methods that are required for this bot to work, and then also the WebSocket methods as well. So let's go ahead and implement the account subscribe, getting actually all I need from this RPC helper class is the ability to get this string, this JSON string. So I'm going to do that right now. So what I'm going to do in here, I already have a class defined. I created a constructor, and what I'm doing is I'm storing an RPC URI and the WebSocket URI as well. So it's all self-contained. So if I ever need to open up another WebSocket with this URI, then I could just pass around the Solana RPC API everywhere. The definition for this, this will be a helper method within Solana RPC API. And what are we going to call it? We're going to call it get account subscribe request. And what am I going to pass in? It's going to be the account address. I'll pass it a string. Oops. So basically, I already have this copied. I'm just going to cut and paste this here. It's basically mirroring this. I don't know if the ID matters. I set it to 420. But basically, it's just this that I'm copying in. And for the address, I have that. That's supposed to change. So I have that as an input. And I'm putting this account address, whatever the caller is using as account address. In our case, we're going to use a token vault address. We're going to pass that in here, and then it's going to create this JSON data object that we can use to send to our WebSocket. That's how you make the request. So it's in here. One last thing you have to do. This is an independent method. It doesn't require I don't know if this makes sense, but it doesn't require a self initializer. You could, but it doesn't really require it because it's not dependent on anything that's in this class. It's not dependent on any state in this class. So I'm just going to put this here called static method, which means that I don't need to put an input called self in here. It just assume that you can call this directly without referencing referencing the instance of this object, if that makes sense. So if you don't understand that, that's fine. Just do this. It'll work. All right, going back. So what we're gonna do now is I updated this code here to actually take in a Solana RPC API, and this is part of the constructor now. So I initialized our RPC API here, and this is where I can use it. So this sub request here, I'm going to replace this with this call, Solana _ RPC API, and then I'm going to call that. Remember that I created that method, and I'm just going to pass in our vault address. So if we test this right now, you should get basically what I just showed you here. You should get this JSON call with this address being replaced. That's it. So the next thing we want to do is we want to send this request over. We want to send it to the RPC node. How do we do that? Well, first step is we got to put it in it's not necessarily in JSON format yet. It's more like a dictionary right now. So what we're going to do is we're going to turn this into a JSON request, or JSON, whatever you want to call it, JSON. I mix it up. So this isn't available. What we need to do right now is we need to go ahead and import JSON. And then now those squiggly lines go away. And the next thing we need to do is we need to send this out the socket. How do we do that? Well, first we got to use await, because this is a call that may take some time, so we have to wait for it to finish before progressing. If you don't do this await thing, your execution isn't going to finish. This won't work. So just do that. So we're gonna go ahead and call send, and then we're gonna pass in our JSON request. And the reason why it's not compiling is because I didn't put self in there, because WebSocket, or I'm sorry, it's WSocket is not defined. And it's complaining that await is only allowed within an async function, so that's your indicator that, oh, we need to make this an async function. Just do this. So anytime a method calls await, you need to make the method async, basically asynchronous. So that's it. We implemented the monitor token. So this will not work currently. We don't have a method we haven't instantiated WebSocket yet, WSocket. So let's do that now. So since this is a thread, this class inherits from thread. That's what this means here. We're inheriting, we're a child of the thread object, basically. So we're inheriting all the features of a thread. So the main capability of a thread, it allows you to run as background. The main capability of a thread is that it allows you to run as a background process type of thing. So every thread needs a run method. So it's part of the class, so we pass in self. And what we're going to do is we're going to go ahead and make an async IO call to run a particular function. So this hasn't been defined yet, but what we want to do is basically we want to write a thread function that will continuously read from the WebSocket. So what it's going to do first is going to instantiate the WebSocket if it doesn't exist, and then it's going to read from it. And what is it going to read? It's going to read updates from the WebSocket. Anything you're subscribed to, it's going to read and do something with that. So let's create this. Okay, read socket. So read socket does not exist yet. So we're gonna have to create it. So this would be an async function as well. So we have to, it's gonna do some work for us. So we call it an asynchronous function. It runs for the lifetime of the software program. So read socket, we're gonna pass in self, it belongs to this class. And that's it, it doesn't need any other inputs. Okay, this thing is gonna run indefinitely. It's gonna be looping indefinitely. So I put while true here. You may wanna have some way to cancel out of this in your own bot version. But for now, this is just a quick way to do this. I want this thing to run indefinitely. And the other thing is with WebSockets, things will go wrong. So what if your internet goes out? What if the server goes down, the WebSocket Helios service? We want to be able to catch those things gracefully. So that's why I include a try here. So it'll allow you to kick out and do something, manage the situation. One example would be if you're using Helios, the server goes down, maybe you want to use a backup server of some sort, then that's where you could do that here. You can handle that sort of situation. So could be really important. So if you got some really large trades going on, you may want to back that stuff up. And I can go over that material in the advanced bonus material for this course if there's demand. Let's see, webs. All right, so typing without talking here. Async with WebSocket. So it's not WebSockets, it's WebSockets. So I'm utilizing this. I'm utilizing this library for connecting to the RPC node. Okay. So I'm going to pass in the URI for the WebSocket or the RPC node. So what is that? Well, just we have it in our Solana RPC API, RPC URI. We want the web service, not the web service, the WebSocket URI. So just a reminder, if you're using Helios, you just go to the Helios website, Helios RPC, log in. I don't care. This is just a free account that I set up for myself. Don't care if you steal my endpoints. Doesn't really matter. But this would be your endpoint for your RPC. This would be your endpoint for your WebSocket, and you just cut and paste that. When you're ready to test, you need these URIs. So, yeah, any RPC node is going to provide you this. Even if you create your own, you're going to have your own. You're going to have your own URLs. Okay. So that's what I'm cutting and pasting here. The Solana RPC node or class will get initialized somewhere else, and we'll deal with that later. But know that this would be the RPC URI, and then this would be the WebSocket URI. Okay. Going back. All right, so we're gonna connect to that. What we do, we need to give this a name. This would be like a temporary variable that we have set up. So we're gonna connect and we're gonna name it WebSocket. So if this successfully connects to your RPC node, that it's gonna kick off this code here underneath. And what we want to do first is we want to go and store this WebSocket so we can use it outside of here. So that's our WebSocket. Remember we had defined this here, our WSocket. We want to go ahead and set that to the WebSocket that gets connected. So now we have that saved. So now when we call monitor token, we should be able to use our WebSocket to send a request because it's a valid socket now. Next thing we want to do is, so if this is a brand, so let's say that our WebSocket failed. It was running, we were monitoring some tokens, it was running, it failed. So what happens, it'll try to connect again. It'll go back here. Since this is a while loop, it's going to go ahead and try to connect to the WebSocket again, reestablish the connection, and it's going to do try to read from the socket again. At that point in time, you have a new connection. So what you have to do is you actually have to resubscribe to whatever tokens you were listening to before. So luckily we stored everything. We stored all the token infos. So we just need to pull those. And so here's what I'm going to do. I'm going to get all the token addresses that we were subscribed to. And I'm going to create a list out of them. And I'm going to get all the token infos. And all I need are the keys. The keys, what are the keys? They're just the addresses, the CAs. So every token's address is unique. So that's a good thing to use as a key. And note that the first time running this, it will not, you won't get anything. This will be empty, right? So it won't matter. But like I'm saying, this is a failsafe. So just in case your WebSocket fails the first time, second time, whatever, you'll go ahead and resubscribe to what you want. So I'm going to loop through these token addresses. And so for token addresses, okay. So for each token address in the addresses list, I'm going to go ahead and I'm going to call the method that we already created monitor token. And the squiggly lines because I need to call on self because it belongs to the class. I'm going to go ahead and pass in this token address from the list, and we should be on our merry way for that. So we have an established connection, and when monitor, let me just walk you through this code. So when we monitor this, it's going to check to see if the WebSocket exists. Yes, it does. We just connected. Oh, I got some redundancies here. Sorry. I need to remove that. I don't need to do that twice. Like I said before, the code is available if you want to get started with the code already in hand, already polished up. It's got comments, everything. You can go ahead and purchase the course, full course. You'll get access to all the course materials. Just a reminder there, and also all the bonus content. Yeah, I'll be doing in the future. So let's see. Okay, so that, yeah, going through this code, the WSocket, it'll check to see if that has been established. And it's going to check to see if we already have this in the token info, but in our dictionary of token infos. Oh, I actually misspelled this. It's not right. Okay. All right. It's gonna initialize token info because it might have already been there. And it's gonna go down here and it's gonna go ahead and make the subscription request. Now, if it does it twice for the same token, it's no big deal. The RPC node already knows that you're subscribed. I believe it'll just throw it out in a second. Any duplicate subscribes, so don't worry about that. But that's basically what'll happen. The request will get sent back to the WebSocket. All right, so going forward, let's complete this. So what we want to do is we want to do another. Once we have an established socket, what we want to do is we want to go ahead and put another try catch here. And then we're going to loop indefinitely on the WebSocket until something happens. Maybe the WebSocket fails on us for whatever reason. Maybe we get a bad JSON format that we're not able to parse. So I'm going to go ahead and just put a try in there. So I'm going to loop indefinitely. And I'm going to try to read from the socket. So when I have received, and then I'm going to go ahead and you need to do an await call on this because this takes some time. WebSocket dot, oh, it's not, yeah, it is WebSocket dot receive, and that's it. So it receives something. We're going to go ahead and try to load it into as JSON data. This is basically why I have the try. statement on this block of code, just in case it fails. It might not be good JSON for whatever reason. So I'm gonna go ahead and pass in received in there. And then after that, I'm gonna assume that I got some good data, and then I'm gonna go ahead and pass it to a function that hasn't been defined yet called process, and I'm gonna pass in my JSON data. Okay, you have to close the try block, and then I'm gonna just do an accept. Timeout error, usually that's what happens, is E, and then we're gonna go ahead and just print E. So the reason why this would happen is maybe there's no activity on this token and it's just hanging. Whatever tokens you're listening to there's not much going on, so it'll probably time out at some point. It's not really it's not really an error to be concerned with, but it will cause an issue. What we want to do is we want to continually receive on the WebSocket when there's data, so that's why we have that as a loop. But if something happens, it's going to time out, and it'll go back to the beginning. It'll go back to the beginning and try to reconnect the socket for whatever reason. Because when there's a timeout error, that means the socket disconnects, and then you got to reconnect. So that's why we do that. All right, so we got to close this try block here. I'll just put an exception Z. By the way, it's good to be very specific with your errors. I'm not doing it here because I'm trying to do this quick, but good practice is to be specific with the errors and manage them accordingly, depending on what error occurs. You might want to notify the client of something, like, hey, your RPC node's down, and so that the operator can do something. Or you can have some code in your bot that does something automatically for you. Okay, so you got this exception as E, and right now I'm just going to do this print. A lot of people will want to log this stuff. You can use loggers, things like that. That's not what this course is about, but you can do your own research on that if you want to make things a little more clean. So that's it. That's our receive. Pretty simple, and that's not too bad, right? So we're just receiving some JSON data. If we get it, we're going to go in and try to process it. All right, so let's go ahead and implement the process. So we can't really run this yet until we get that done. So let's go ahead and define a process method. By the way, this is probably going to be your most complicated class right now on this lesson. So if you're getting this, good. If not, just stay with me. You're gonna start flying after you start coding this up. You'll start getting it, I promise. If you got any questions, put it in the comments. Okay. So I didn't explain this, but the input to this is data, the data dictionary. You kind of know. What I'm passing in is the JSON data. So that's what I'm passing in. And I'm assuming everything's good with this. It's good data. So I'm going to do a check to see if it has something that I need. So if it has an element called params, then I'm going to go ahead and this is a safe way to get the extract JSON data. So I'm extracting the element called params from this JSON data. I'm going to show you in a second what this means. So going back to the account subscribe RPC method, you can see on this website what you're going to get as a result. So you're gonna, on each event, it's going to send you this information. So what it's going to send you is something that looks like this. That's why I'm checking for a params entry here. So I'm checking for this and I'm trying to get the data in there. I'm trying to get that's highlighted. So that's all I'm doing. So if we got some params, I'm gonna check, just do an if statement. If we got params, then I'm gonna go out and parse the info. I'm gonna assume everything's there. If not, if it's a malformed JSON message, then we'll probably be in trouble here. It'll probably kick out an error, and that's why I have a try catch on it, just in case that happens. Or not a try except. Sorry, I'm thinking about C# here, Java, that they use that terminology, but in Python it's try except. All right, so parse info. I'm going to assume everything's there, and you can go ahead and look at the JSON format to kind of figure this out yourself. What the tree looks like. So under params, we have a result. Under results, let's see, we have a value, and under value we have data, and then under value we want the data likely that's under value. So like lamp words, things like that. Those are things that you might be interested in later. But in this case, what we want, I'm going to show you straight up what we want. Want result. We want value. I'm just going walking down the tree here for the data I need. Data. Yeah, it's far down the tree here. Parsed. And then I want info. That'll give me the parsed info. And you can look back at the JSON format to see what I'm talking about. What I really want here is the token address, because I could be subscribed to lots of tokens, so I need to pull in what token address this belongs to. And what you can do is you can take parsed info and take a look at the mint. So the parsed info is just the info element basically, and then under that is a bunch of other things like mint. And the other thing I want is the token UI amount. What is that? Well, that's just the amount of tokens inside that account. So the number of whatever token you're dealing with. It tells you exactly what the amount is. So if there's 900,000 tokens in there, it's going to say 900,000. So UI amount. You want UI amount, not just amount, because there's another one in there that's labeled amount. You don't want that one. So I'm just going to paste this. So UI amount is what you want. If you put in amount, it's going to return a big number for you. What it is it's a scaled number. It's not what you want. You would have to convert it into something that makes sense. So anyway, just use UI amount for now. There may be a use for using just amount later, but like if you want to optimize things and make things work faster, there might be a reason to use that instead. But just use UI amount. It's more readable, and you don't have to make any scale adjustments or do any math on it. All right, so the next thing we want to do is we want to grab our token info from our dictionary. So I'm just gonna set this to, just so I don't confuse you, I'm just gonna grab it from the dictionary. So there's a way to do it directly on the dictionary itself, but I'm gonna just show you this way. Token info, I'm grabbing it from the dictionary. Token address, okay. And what I want to do is, I'm assuming that this exists. So at this point in the code, it should exist, right? I haven't provided a way to remove the token infos. That's something to consider though. This might error out if you don't have a token info. You could do a check on it. If you're like if token info, you could do a check on that to see if it's valid. But I'm not going to do that here. I already know it should exist if it got to this point, because we're subscribed to this token. Based on what is in this token info, what I want to do is I want to update the token vault UI amount. Vault UI amount. So going back to the tokens API, that's not defined in here, so we're gonna have to put it in here. But let's go ahead and just set this to the token UI amount. We want to keep that updated. Okay. So the reason for this is that we're getting this information off of the chain, off the blockchain. So we want to go ahead and store it. I don't want to have to pull this information again. You can make another RPC call using an HTTP method to query this, but since we're getting it off the chain automatically, then it'll save you some time. It's more efficient to just save it now. So let me go ahead and add this to this. Pretty simple. I'll just add it below price here. I'll just set it to 0. I'm going to add a self to that because it belongs to this class. Okay. So we're good. We're green there. Did I spell it right? Yeah, it's fine. All right, so now that we got that straightened out, let's go ahead and, what do we want to do now? So we have a token update. This vault changed. That's the only way we can get in here is if the vault changed, right? That we're listening to. So what we want to do, the next thing we want to do is we want to track that we've updated this token, and you'll see why later. What I'm going to do is remember we created this variable here up here called updated tokens. This is how we track which tokens have been updated. Okay, we'll go ahead and add the token address in here. So now that if the caller wants to see what's been updated, they'll be able to look it up. And they'll say, oh, okay, these tokens have been updated. The next thing we want to do is we want to go ahead and notify any subscribers to this. So I would call this, this is utilizing a pub and sub framework. So very simply, this is going to publish this information to something called a topic. And how do we do that? So I want to publish this information to a topic, and there could be other classes, other components in your software that are listening to that topic. So when anything gets published to that specific topic, then those consumers, those components that are subscribed to it will receive those updates. It's a decent way to decouple your code from other components. So I'm publishing to this topic. I don't have to have any knowledge of those other components. Those components don't have to have knowledge of this class either. All they have to know is that there's a topic out there that has the data they want. That's exactly what I'm going to do. So I'm going to go ahead and call pub, and I'm going to call this thing called send message. And I have to give it a topic, name, an input. So the input is topic. So this would be an input. This is another way to express inputs for a function. So this is just a feature of functions. So typically you don't put the variable name equals, but if you want to like change the order of your inputs and stuff like that, would be a way to do that, and it's just convenient here to do that. So I'm going to set the topic name equals globals dot. This is something that doesn't exist yet, but I'm creating a new topic with this name. Update event, and the argument for this is going to be the token address. So this might be a mouthful, but basically what I'm going to do is anytime this occurs, I'm going to publish on a topic named topic token update event, and I'm going to pass information across that topic within this argument. So that's why I have this arg1 equals token address. So anytime somebody subscribes to this, they know that they'll get alerted that there is a token event coming, or there's a token event that occurred, right? And they need to know which one for what token address. That's important to them. So that's what I'm passing through. You can pass through anything you want through here, but I'm just passing right now, I'm just passing the token address. So let's get rid of these squiggly lines. You're going to need a package for this. It's a pub and sub framework, pretty commonly used. So what I need to do is I need to import from pub sub. Let me reorganize this a little bit. I just like to put my froms before anything else. All right, so from pub and sub, import pub. Okay. And now the squiggly lines went away. So we're done here on this one. So when prospects gets called, then we're gonna call this. We're sort of done. This topic doesn't exist yet. So what we're gonna do now is we're create a new globals file. This is a file that has shared information between classes or between files. Use it sparingly. It's not a good idea to use a lot of globals in your software. Just not good practice. But we're going to use it in this case to store our globals. So we're going to have something called globals, and then we're going to define this topic name. So it's going to be a string. Actually, I'm just going to name it exactly what the variable name is. Then we're done. That's it. That's all we got to do there. Yeah, we could store other things in here that we want to share between classes, but I'll save that for later. Let's go back here. Still, globals doesn't exist. It won't compile yet. What we need to do is bring it in. So with the import, so what I'm going to do is import globals as globals, and then now see it turn green, and so it's all good now. All right, so let's go back to our market manager class. We have enough information to fill this out now. So we're sidetracked by implementing our Raydium tokens monitor, so we're going to finish that. So we know that this needs a Solana RPC. To instantiate this, we need a Solana RPC. node. We're going to call that the Solana RPC API. Where are we going to get that? Well, we'll go ahead and pass it in this constructor as well. So, oops. We're going to pass it in, and it's going to be just cut and paste here. Solana RPC API. Okay. Well, it doesn't exist. It's got squiggly lines there, right? So we gotta cut and paste this. So we're gonna have our client configure this. So we haven't developed that code yet. So the client will go ahead and put it together. It's because you're gonna have your own unique API you need to initialize. We need to allow the client to initialize that stuff. It might be stuff that they enter in the GUI user interface, a website, whatever. So that's why it's a configurable item, so it needs to be passed in. So it's complaining about the Raydium tokens monitor. Well, we haven't imported it, so we do it from. Let me go and move my imports here. From Raydium tokens monitor, import Raydium tokens monitor. Okay, it gets rid of squiggly lines. And I believe we're good here. By the way, if you hover over this, it tells you what you need to, what your inputs are. So that's a nice feature. So next, what we need to do, we had a pretty simple way of getting the price. We're just calling tokens API, which is fine. We'll leave that, but we're gonna modify this a little bit. Now that we have a pools monitor, why not use pools monitor for getting the price instead? So if a pool exists, then we'll go and pull it from the pool. This saves us from having to make the Raydium API call. Remember I said if you do that too much, you're gonna get shut down. That saves you from doing that. So now we're using the pool. So let me go ahead and create a rep price. None. I'll set it to none. This is to be the return price. I'm going to attempt to get a token info out of the pool. So we have a Ray pool monitor. I'm going to go and pull that. This function does not exist yet, but we're going to create it. Create get token info. And what do we want? Well, we want to pass in our token address into this thing. So if we get something, we'll go ahead and pull the price that way. We'll go ahead and initialize price to whatever the token info is. And of course, token info, remember, has a price. And we go in here, see it has price. That's what we want. Dot price. We don't have a token info, that means we're probably not monitoring that token. So we'll just do it the old-fashioned way and just use the Raydium API. Just leave that code as is. Okay. And the last thing we want to do, we could just do the return here. Actually, yeah, never mind. Just delete that. No, we'll just return it straight from there. So that's it. This won't work yet. Why? Well, we need to implement this get token info. So let's go and do that. So let me just copy this right now. I'm gonna go in there in the Raydium tokens monitor. I'm going to, doesn't matter where you put it. You want to have some sort of organization in here. So I like to organize things a little bit. I like to organize the internal functions. If I didn't mention already, I start internal functions with an underscore just so I know that these are for internal use only. There's a way to make them private so that other outsiders can't see them, but I'm not going to do that right here. So trying to get this course done as quickly as I can. So we got a method. We need to have this to be, since it's part of the class, we need this to be self as a first input. The next thing we got to do, this is pretty straightforward here. So remember we have this token infos dictionary. So basically we're going to check to see if we got a token infos in there. So we're going to go ahead and do a check for that. Actually, I'll just cut and paste this since I already have it. If the token address exists in tokens info, I'm going to make sure that this is not, this hasn't been, hang on. The next thing I'm going to do is I'm going to check to see if this token has been updated. So if this token address is in the updated tokens, I'm going to go ahead and update the token info. And I'm going to create a little convenient method for doing this. There's a little bit of math involved. Update price. There's a little bit of logic involved with this. Update the price based on the token address. Actually, all right, so once we update the price, we'll implement the update price in a second here, and you'll see why I kept it as a separate function there. The next thing we want to do is once we've updated the price, I'm going to go ahead and remove it from the updated tokens because it's already been updated. So this function took the initiative to go ahead and update the price. So I'm going to go ahead and remove this token address because it's obviously been updated already. The next thing I want to do is I want to go to return the updated tokens. And I'm going to go ahead and I'm going to go ahead and return the token info. I'm going to return this token info. That's it. So if else, well, I don't need to do anything. The else would be just returning null by default. You could define it. You can define it as a return, just if you want to be specific about it. Return nothing if it did not find one. So last step here is to define the update price. So I'll go to do that down here. Update price, and then I'm going to be given a token address. That's going to be a string. Okay. I'll go ahead and do a double check on to to see if the token address exists. I'm assuming that this call may be called somewhere else too, so that's why I do these double checks. It really doesn't impact anything performance wise, so it's fine. Nothing noticeable. So I need to give this to self. And what I want to do now, I want to pull the price. So the one thing that we know that we have is the token vault address. That has been initialized. It has to be. Every time the token updates, then it's going to update the token vault UI amount. So that's what we did here, right? We know that that's updated. It's something that we subscribe to, right? Well, the next thing we need to do, in order to get the current price without having to call the Raydium API, is to get the vault account, get the balance of the vault account that holds the SOL. So that's the other end that we need to calculate the price. So that's what we're going to do here. So what we're going to try to do is essentially just find the SOL balance of the vault account or the SOL reserves. So let's just do that. We'll use our Solana RPC. And we're going to go ahead and we're going to call something called get account balance. And let me go ahead and initialize this vault address. We'll call it SOL vault address. And we're going to pick out the token info for this, and we're going to go ahead and pick out this value, SOL vault address. Remember, we initialized this when we got our subscription response. So based on this, we get the SOL vault address. We're going to pass this into the account balance, get up account balance. Now we haven't implemented this yet. We're going to have to go and do that. Let's go do that now. So in this RPC, let's implement a method that is called get account balance def. Okay. Get account balance, and then what are we passing in? Account address. I'll just cut and paste this in there. What are we returning? I usually like to put returns here, so I know. Well, this is going to be floating point. It's just a number that has a decimal point in it. That's all. That's what a float is. So how do we do this? Well, in order to do this, you need to make our HTTP method request. So going back over here, if you go back to your HTTP methods on your Solana, on the Solana API page, get balance. This is what we want. This is what we want to get. Like with the account subscribed JSON, it's kind of similar. It tells you what the format is for the JSON request is and what you're going to get back. So this would be the JSON request. Right now, this is showing the example in curl. But anyway, this is the JSON request here. It's calling the method get balance and then passing in these parameters. It's very similar to the account subscribe JSON. So going back to the code, I'm going to create a little handy routine here that will account for most HTTP method calls. So let me go ahead and call that. So let me just try to stub it out. So this response, we'll be expecting a response by calling this method, and this is part of class. So what we're gonna do is we're gonna call this thing called run RPC method, and what is it called? It's called get balance. Very important that you get this right because it's gonna use this to it's gonna put this in the request that the RPC node is gonna read. It has to be a valid name. So get balance. This is how it knows this is a signature for that method. It was the same thing with our account subscribe here, but just letting you know. And the next thing we're going to pass in is a list of parameters. Right now we only have one parameter, which is the account address. This is how you specify a list of elements, by the way. So you follow it with, or you start it with a bracket, opening bracket, and then a closing bracket. And you can put multiple things in here. That's why they call it an array. So if I have multiple addresses I wanted to subscribe to, you potentially do that. But for this, we just need one. And so the idea here is to utilize that method to do that. And let me get rid of that. The next thing we want to do is we want to go ahead and check to see if this response is an actual response. So we're going to make that method return none if it's not there. So if we do get a response, we're going to assume that everything is good. And we're going to, the account balance will be a number. The number is going to be in lamb ports, I believe. So what we'll have to do is we'll have to do the math on that to see what that is in Sol. Yeah, just know that this method right here, get balance, will return your Sol amount in something called lamb ports. It's just a fractional version of Sol amount. So 1 billion lamb ports is equal to 1 Sol. So when calculating fees and stuff like that, it likes to usually internally within the blockchain programs like to use lamb ports. It's a lot easier to work with. So that's the reason for that. But just know that we're going to, if we want to convert this into something that's readable by the user, something the user understands, we'll probably have to convert it back into Sol. But let's just assume that that we're all good. We're going to run this RPC method. If the response is good, then we're going to go ahead and pull that information from this response. And what we're expecting is something called .result. And underneath that is the value. You can look back at the example on the web page. You can look back here. This is basically what we're extracting. This value here, that's what we're extracting. So it's 0 right there. We would get the number of lamb ports in that account, or amount of Sol. We convert that to the amount of Sol. And we'll do the conversion a little bit later, but right now let's just pull the value out. If we don't get a response, we'll go ahead and just return none. Do whatever you want. You can turn an error, whatever. It's your code. So let's go ahead and create this run method, run RPC method. So this is going to help us. So notice that there's a lot of HTTP methods that we can use here later. We might be using. So that's why I created this little helpful method here, so we don't have to duplicate a lot of code, because a lot of the behavior is similar. We just need to pass in the right parameters. So let's create this. We'll go ahead and add in a request name, and that will be a string. So we know the inputs already because we used it here, right? Get balance, and then the next thing will be an array of parameters. So we'll just call this params. And you can define this as an int array. I can't quite remember how to define the type there. I think that this is how. Never mind. So that's okay. I don't need to put that there. But just know that that's an array. All right, the next thing you want to do is you want to create the post request. Well, I'm going to create this response here, and I'm going to use request. We've done this before. It's similar. Remember we did a get. This one's called a post request to the HTTP. It's an HTTP post request. And what we're going to pass in is the URI, the RPC URI. So instead of the WebSocket URI, we're passing in the RPC one this time. The next thing we're going to pass in is we're going to initialize an input called JSON. And we're going to call that request. We're going to make a call to request just to make things a little more readable here. I don't want to do everything. You can do everything inside this, but I want to make things a little more readable. So I'm going to call this JSON request equals request. And what I'm going to do is pass in the request name. And then I'm going to pass in the parameters, or I'm going to initialize this parameters variable equals params. So I'm going to take this JSON request and I'm going to set that here. Let me get rid of these squiggly lines here. What I need here, I need a JSON RPC client. So I need to import some of this stuff here for making the request, the JSON request. So what I'm going to do is import requests. That's why. All right, so now I got rid of all the squiggly lines. I'm good here. This might be a little confusing, but understand that I'm just making the JSON requests, and I'm utilizing these packages to do that. Just makes things easier. There's other ways to do it, but this one's the easiest way. So I'm creating the JSON request, and I'm passing this into this post. So this is making a call to the RPC and posting this command to the RPC, and I'm expecting a response. And the next thing I have to do is I have to parse that response. So I'm going to call this parsed. Parse response .json. Okay, so there's two things that could happen. This could error out. I might get a bad response. So this is what I'm going to do. I'm going to check to see if this parsed data is actual data or if it's an error. So that was the package I or this is the class I included the error just to check to see if if I'm extracting an error. If it is, it must be an unsupported method probably. So I'm just going to return to the caller none if that happens. Else, I'm going to go ahead and just return whatever was parsed. The reason that I'm returning none is because I don't want to return something that's not proper, that is not filled out properly. So I'm guaranteeing that if I don't get a good response, if I get an error response, I'm just going to pass back nothing, and then the client can do whatever they want with that information. So we're done with that. We should be able to make that call. We need to fix this, so I forgot to make this part of the class itself. And now we're done with that. So now we have a way of retrieving account balance. So as we go through implementing this bot, we're probably going to be in here a little bit, creating more of these functions that mirror what you see on here so that we can gain access to the blockchain. All right, so let's finish up our code for calculating the price or updating the price. So now we should be able to get the SOL balance of that vault. So potentially we can calculate the price now. We have the vault, both vault balances filled out. We should, the most current. So to do that, we have to do a little math. It's not hard math, but it's a little bit of division. So in order to do that, we'll go ahead and, first of all, remember that SOL balance is in LAN ports? Well, let's convert this into SOL. So how to do that, we'll go ahead and divide by 1 billion. In order to represent 1 billion, you can type in 1 billion here like that, with all the zeros. Or you can just do this, 1 to the 9. That just means that there's 9 zeros preceding, or not preceding, after the 1. So we want to divide our SOL balance by that. Notice that this syntax here, the divide equals by, you can do this. Some people might find that confusing. You can also do this. So it's the same thing. So I do it shorthand because it's just faster, that's all. So that confuses you. That's the explanation there. So we're going to check to see if the SOL balance is actually, well, actually we should check the SOL balance. Check that we received something, because the potential is there that this RPC call got nothing if it was a bad RPC call. So you can make a judgment there. You can do what you want if that RPC call was not good. So we'll go ahead and check to see if SOL balance is okay. Next, we'll do the conversion to SOL. And then the next thing we're going to do is we're going to set the price. So this is where we're going to do the math. Remember I showed you on the diagram? Basically, you take the amount of SOL divided by the token reserves, and then that equals your price. So we're going to take our SOL info, I'm sorry, we're going to take our token info. So I'm going to use the token address. We're going to pull that out of the dictionary. Token info. Let's just pull it out of the dictionary. This is how we've been doing it, right? Okay. And then what we're going to do is we're going to set the price of it. Price equals. We're going to take our SOL balance. And we're going to divide that by our token info dot, remember we stored it, token vault UI amount. Let's just put in a little more extra protection here. We want to make sure that our token vault amount is not 0, because what'll happen is you can't divide by 0. So, on the off chance that UI amount was never filled out for some reason, I don't think that could happen, but want to double check that doesn't happen. So we'll add that condition here. We'll make sure that that's greater than 0. So that is it. I believe that includes the implementation of the Raydium tokens monitor. How about we try to test this to see what happens? Let's do it. So if it doesn't work, then you're going to learn some debugging. You're going to learn how to debug, which is going to be pretty vital when you're dealing with this stuff. All right, so let's go back to Market Manager. So if we get the price of a monitored token, we'll check to see if it exists in our token infos, if we're monitoring it. If we're not monitoring it, then we return nothing, because this pool isn't. It would have to be monitoring it for it to return anything valid. So that's the client's fault. If they call this without having an initialized or monitored token address, then they'll get nothing. And that's okay. That's what this is supposed to do. So next step here is to kind of tie everything together. So we have our market manager, we have a Raydium tokens monitor. The last step here is to create some sort of client. We're not going to create our UI client yet. We're just going to create a little command line interface so that we can tie everything together. So let's go ahead and do that. So remember this picture. So basically we just created this market manager here. We created blockchain API, part of it. So the last step here on this lesson is to create this client. This will be a very, very crude client, just so that we can test our market manager ability. So notice this component is composed of a lot of different components inside. So you saw that already. We developed a lot of those things. This includes the Raydium token monitor. So that's all a part of the market managers. That is all part of what market manager is and the services that it provides. So going back to the code, let's go ahead and create a main class, main.py. So this is going to be your command line client. Well, let's go ahead and start our main. We're gonna create a function called main, and we're gonna make it async, because there's a bunch of threads going on, threaded action. So there's calls that we need to await. So that's why I make it async. Okay, here's where we define our URIs. Let me go ahead and define the HTTP URI. This would be for our RPC node. Let me go ahead and grab that information really quick. Remember I told you I'm just using this to test. This is the free account. You can create yours too for free. So I would utilize the free account for testing. If you want to do anything serious, you probably need a paid account or a custom node, or your own hosted node. And there's advantages to doing that. It's mainly speed. You get faster response times when you use better RPC nodes. Okay, so I got this one, and I'm going to paste this one. I believe this is WSS. Yeah. Same thing. All right. Later on, I'm going to show you how to keep this information secure, but for now, I'm just putting it right here. Don't worry about it. But that's in a later lesson. I'll just teach you how to do that later. So we're going to create a market manager, and that will equal. Well, let me go in and import it first because we don't. This file doesn't know anything about that. So we're going to do it from market manager import market manager. By the way, notice how I stored everything in one folder. There's a way to better organize things, like if you want to keep things in separate folders and things like that. There's a way to do that, but I won't do that here. I just didn't want to overcomplicate things. There's additional setup that you need to do that in Python. So I just keep everything in the same folder in this case, just to simplify things. But when you're doing a lot of development and your bot grows, or your code behind your bot grows, and you probably want to organize things. So it's all up to you. So let's take our market manager. Let's initialize that, call the constructor. Oh, we need a Solana RPC API, so let's go ahead and create that. Solana RPC API, and I'm going to create that. So of course the program knows nothing about that, so what I'm going to do is create it, or I'm going to do an import Solana RPC API. API dot, okay, or I'm going to go ahead and initialize this with the HTTP URI and the web service, or I'm sorry, not the web service, the WebSocket URI. Okay, so now we have that initialized. I'm going to pass that into the market manager. And what I want to do now is I'm going to go ahead and start the market manager. So that's what, when you go into market manager, you notice that it is inheriting from thread. That means this is a threaded object that you can run it. That's why we needed a run method of some sort. So now that I'm thinking about it, there's one missing element to this that I'll get to, but let's go ahead and continue here. So what do we want to do? We want to go ahead and start our market manager. So we want it to monitor the state of tokens that we care about, and we want to utilize it to pull token information like price. In this case, it's just price because that's what we implemented, right? For user input, I'm going to allow the user to enter in a token address. Pretty simple command line. Please, or just, I'm going to have it say enter a token address to monitor. Okay, so that's going to query the user for some information. So the token address, so that user input would basically be the token address, and let's just assume that it's a good token address. What we're going to do now is we're going to go ahead and make a call to the market manager to monitor this token based on the user input. So that should kick off some things. The Raydium tokens monitor should get subscribe. At this point, it should subscribe to whatever token the user answers. And in order for this thing to keep on running, I just need to make this call really quick. This is just temporary, but this is just to so that the program doesn't quit on us. So basically this will do is it'll allow the program to keep on running indefinitely. So we're just going to call this join on the Raydium pull thread. So that is the definition of our main. Outside of here, we need to actually call our main. So I'm going to do, since this is an asynchronous call, I need to call async IO. And of course, we haven't imported async IO. We got to call run. And then we'll pass in main. That's it. Potentially we could run this, but I already know that this is not going to work yet. So we implemented a lot, right? So if we go to monitor token, it's going to call the Raydium pull and then go ahead and call the monitor token, and then the subscription should be set. We have one issue here though. And let me see. One thing about this is I was actually thinking too far ahead. This market manager doesn't actually need to be a thread just yet. It will in the future, but I'm going to take this out. The only thing that needs to be really a thread right now is the Raydium tokens monitor. So just realize that was just a little mistake on my part. So I'm taking that out. And let me see. So what we do need though, what we do need to be able to do is we need to be able to subscribe to the updates from the token monitor. So here we go with that. This is just the one remaining piece. What we need to do is we remember in this Raydium tokens monitor, when we read from the socket, we call process if we get some data, an update. Remember this publish thing that sends the update out the topic token update event? Well, that our market manager needs to listen for that. How does it do that? Well, first of all, we gotta import the pub for that. Okay, we're gonna import globals and we're gonna import the pub class. So going back to market manager, let me go ahead and do that. I'm gonna delete this threading because we don't need it right now. We got the pub. Of the next thing here, we need we're gonna import, let me move that. We import globals as globals. Or not, it's case sensitive. So in the constructor here, here's where we can define our subscription. So now that we have this pub thing added to our imports, we can make a call to subscribe. There's a subscribe method, and we need to listen in on that topic that Raydium tokens monitor is publishing to. Globals.topic token event. And we need to set this input variable called listener. We'll go ahead and set listener equal to a function that we'll create. So we're going to call this, it's an internal function, so I'm going to preface it with an underscore, and we're going to call it handle token update. Okay. So we need to implement this. This handle token update. I'm going to put this down at the bottom. Handle token update. It's part of the class, so I call it self. Or I add self as the first input. And remember this. Going back here, it's very important that you get this right. arg1 equals token address. So you have to match this, because when you subscribe to this topic, it's gonna specifically look for this input, arg1. So if the inputs, you can have more than one input or to this whole thing. Like if you want to output more information, the publisher could do that, but you just have to make sure it matches. That's all. So arg1 is there. I think that the variable names have to match, so I'm going to call this arg1 too. Or I'm just going to call it arg1. And I know that this is a string. It's just a token address, right? So later on, you might want to name those things more meaningful things like token address, but I'm just leaving it as arg1. So what do we want to do with this? So once we have an update, for now, this is what we'll do. I'm going to go ahead and take that price and actually we have to get the price. So this update is just telling us, hey, the vault's changed. That's all it's telling us. So now we actually have to go get the price of this thing. So we're going to go ahead and call it get price based on the argument. So we're assuming we're getting a token address. We're going to pass in that. And what we're going to get is a number, right? So all I want to do right now is just test it, right? Later on, you might want to do something with it based on your logic, based on your strategy. But right now, we're just kind of testing the waters. Okay, are we getting the right price? We're subscribing to these updates. Are they coming in correctly? This would be your time to validate this part of the code. So this new price, we'll go ahead and make a string out of it so that we can print it out to the screen so the user can validate what's going on. And this is just how you do it. This is one way to create a string out of a number. So we got this new price. So I'm just gonna say that this is the new price. And what I want to do is I want to show it up to a certain amount of decimal places. So don't worry about this, how this looks. Basically, this is just indicating that I want to turn this price, which is a number. It could be a long number. It's probably going to show up like this. If it's like a Solana price, it's probably going to show up like this. You've probably seen this in your deck screener. Like it might show up like that. So I don't want it to look like that. Basically, that's telling you that there's 5 zeros. What I want is this. I want the price to look like that instead, right? So that's what I want. So that's all it's doing. It's formatting this string so it looks like that. So you can play around with it. And then the next thing I'm going to do is I'm going to go ahead and print it out. This is temporary code, by the way. You don't want to keep it like this. This is just for demo purposes. Your final bot will have some logic in there to do something with it, this new price change. Like say if it's something that you've traded and you want to monitor that price, you have some alert system. Hey, price is too high, or you may want to invoke some sort of action because of the price change. You might want to track the volume. You can use this to track volume, all kinds of things. So there's a multitude of things, and I'm going to show you some things that you might want to do with this when you build out your bot. So let's just do this for now. Let's go ahead and print it out. I'm going to print out the argument 1, which is the token address. It's going to print out price was updated. And I have this exclamation point because I'm very excited about it. The price, I'm going to print out the price. And what I'm going to print out is the new price string. Okay. And that should be that. Just 1 second. Let me just correct something. I need to actually add in something. I'm going to be more specific here. I need to identify the topic name. I need to identify this as topic name because I'm not sure the order of operations is in the right order here. I had to check the signature here. So technically you're supposed to put the listener comes first and then the topic name. So I have it at things in the wrong order. But if you specify the actual input names, you can put them in any order you want. That's just what I'm doing here. So hopefully that's not too confusing for you guys. All right, so I'm gonna go ahead and do a little demo here just to make sure things work. So let's get it. All right, one more thing. So this thing failed on me. The reason why is remember I removed the threading. I tried to call start on it. That does not work anymore since I removed the threading inheritance. Remember I inherited from thread and I just removed that. So let's get it. Let's try again. Let me go and start it. All right. So here's the terminal here. So down here, it's basically asking me to enter in a token address to monitor. So let me go ahead and do that. All right, so let's choose a token to monitor. I'll choose Pox. Okay, Bark Meta. Call them a bunch of scammers, if you will. But anyway, they got this pretty successful token out there. So I'll just get this address here. And let me go ahead and try to run things here. I'll go ahead and press play. There's a problem here, and I'm going to show you how to debug through it. But anyway, it's allowing me to enter in a token address. I'll enter in this Pox token address. I get up an issue here. It's saying that if you look at this error here, it tells me that a monitor to token was never awaited in Raydium tokens monitor. So that kind of gives us a clue what's going on. So let me dig down in here, go to the definition. I'm going to stop the debugger. I'm going to go here, go to the declaration actually. And yeah, so this monitor token is an async function. So what I need to do is I need to call wait on this. Yeah, I forgot that. That's what happens. It just shows you what happens if you don't do that. I need to make this an async function. And then up here in the main, I'm already doing a wait, so I'm already doing the right thing. So let's try again. Call it again. I need to grab the token address. Go back here, grab it. Okay, I still get an error. Can I join thread before it started? Oh, So there we have another issue there. So let's see if we go into the constructor. This pool monitor hasn't even been started here, so I can't join it because the pool monitor never started. So let's go ahead and after we do the subscribe, let's go ahead and start the pool monitor here in the constructor. Typically, it's bad practice to start threads within a constructor. That is one reason why I had made this a thread to begin with, this market manager thread. But don't worry about it for now. We'll adjust it later. Yeah, typically I don't do this, but I'm just doing this for simplicity's sake. So anyway, we need to start this pool monitor thread in here for now. We could put this into a run method if this was a thread, and that would probably be the best way to do that. But for simplicity's sake, I'm just putting it here. Let's go back. All right, let me go grab the token address again. How's this token doing, by the way? All right, so let me restart. And we still have some issues. Just 1 second. All right, so one slight correction. If you go into your Raydium tokens monitor, go into your line 65 here. In your read socket function, token addresses, I have this as key. I'm looking for the keys in the token infos. Well, there's no key. There's no key in there. There's no key function. Basically, what I need is keys. So I'm going to correct that, and I'm going to retry. All right, so there's one little issue, and I'm assuming that the call from Raydium, the Raydium API, was going to give me the Sol Vault address in mint A as mint A. I thought it was assumed that it was mint A, but it's not. The token vault address was in mint B. So apologies. My last spot that I created was mainly just for pump fund tokens, so this is just something new that I ran across. But there's a way to fix this, and I'm going to show you how to do that right now. Just to describe the issue for you, let me go ahead and run this through debugger really quick just to show you. This kind of will show you what you guys will have to do if you encounter problems like that. Let's see. It's not too difficult. So I'll go ahead and add a breakpoint. It's going to ask me for a token to monitor. I'm going to enter in the POX token address. So this is where I encountered the problem. So it created this URI for me. So let me go ahead and cut and paste that into a browser and so you can see better. So I'll just put that, I'll put this into my browser, make it pretty. Unfortunately, the mint A assigned to the POX token, I was assuming that this would be the Sol token. And it looks like, never mind. What? Okay, so this is trippy. It was reversing them. It was saying that the POX token was mint B. And it swapped them around, which screwed up my coding. And now things look right with the price. It's converting the price, no problem. So I don't know what the issue is. Hold on, let me run it through again. Okay, so I get this new URI, and this looks fine. This looks completely fine now. So it says my vault A is this token, and we can check it in SolScan. So this should be represent my MPOX token, and that's correct. So the mints match up. I can't tell you why it reversed them before, but it looks like that's something that could happen. So we should be able to prevent this. So unfortunately, I'm gonna have to implement something else to prevent that from happening. So if these get swapped, we need to make sure that we choose the right vaults, because that's really important when doing our calculations. So let's get into that. It's pretty simple, really. It's not a big deal, honestly. But this is the first time I run into this. I don't do a lot of Raydium token swaps, so I usually just work with pump fund tokens. But anyway, this is totally solvable. So the first thing we want to do is we want to go ahead and hold on to um, our vault A. So we'll go in this code here, just in case you don't know where we are. We're in the tokens API, and I'm inside the get m token pool data method. So down here around line 44, I'm going to go ahead and add in a new variable to store the, actually I should just cut and paste this, the vault A. And I'm going to go ahead and store vault B. It's good that you're seeing this firsthand, seeing me work through problems, because this is a good skill that you're going to need to have. You know, when you create your bot, if you want to tweak it up, you want to tweak this bot to do exactly what you want without error, you're going to have to get a little more familiar with this. But it's not too hard. It's pretty easy. It can be fun. So the next thing we want to do is go ahead and check to see if the other thing we want to do is we want to pull out the mint address for token A, for the vault A. If you go back into the structure of this whole thing, so you got mint A defined here, and you got mint B defined. So this has everything you need to identify mint A, what mint A is. It's got your address. So if these things were swapped, mint A could be sold. So what I want is just to extract the mint A address. So let's do that. I'll put that up ahead here. So I'm just going to extract the mint A address from the JSON data. Let me just cut and paste all this. So it's going to be this. Oh, all right, data. And it's going to be mint A. And then the address. And I should be off and ready for the mint A, with the mint A address. So that should be it. So now we're going to check to see if the mint A address is equal to, remember we entered in our token address to monitor, or to get the liquidity pool data from. So we use this input token address, we match it up. If it equals that, then we can assume that belongs to the token vault address. So we're going to swap these. Let's go ahead and swap these and say that our token address, go ahead and initialize it to vault A. And our sole vault address, we're going to initialize it to vault B. Now, if it's not, if mint address A does not equal the token address, that means it's swapped. So we got to do the same thing. So let's cut and paste, except we just got to swap them. Pretty much the same thing. So sole vault in this case would be vault A, and our token vault would be equal vault B. That's it. I believe that's all you need to do. The other thing we could mess with, remember I did this hokey thing with the price? Well, we can make it a little more accurate here. So in the case that it swapped, let me go ahead and adjust this. Remember, I did a check to see that the price. Yeah, so the price is greater than 2. That's kind of a hokey way of doing it. That was kind of a kludge. So here's a better way of doing this. So I'm going to cut and paste this. I don't need this if statement anymore, now that I know what I know. So if mint A is equal to token address, so the price will be correct. So what we can do here is, what we can do here is set the token price, token info correctly. Info dot price. We're gonna go ahead and set it correctly. It's just gonna be well, actually we already set it up here, right? So we don't need to. We actually don't need to do that. Sorry. We don't need to do anything. The price should be fine if it's in that order. If mint A is equal to the token address, the price should be fine. If it's not, we get this case where it's swapped, then we're gonna get that large number, which gives us the number of tokens per sol. So that's where we need to do this. So that's it. So that explains that. I don't know why they swap them sometimes. I don't know why that's the case, but it looks like that happens. So we dealt with it. So let's go ahead and retest. Right, found one more issue again. So I'm in the debugging phase. It's normal to find a few issues here and there. It's always good to unit test these things as you build them. So I would probably caught this earlier. But anyway, here's the updating the price in your Raydium tokens monitor. So there's a part here where I don't have. I'm checking a condition to see if the token vault amount is greater than 0. So in this case, it's not. So I have to, or I'm sorry, in this case, this doesn't exist. This token info doesn't exist. So what I need to do, let me go ahead and just put this over here. I need to initialize this token info so I can get that information out. That's it. It's a pretty simple mistake. So I will test again. All right, so I got something working. Just one more thing with the printout. It's not printing out exactly like I want it, so I made a little mistake here. I go into the market manager, I wanted to print out the new price with a certain amount of decimal points showing the zeros. And basically I just need to do this. I need to put the bracket in the right place. So let me go ahead and start again. I'm listening to another token now. I want to go ahead and listen in on this one. This one seems to be more active than the other one that I was looking at. So now I'm getting price. So there you go. There's your price. And if you want to confirm this, you can open up Dex Screener. You know, this is getting on the chain information. This is calculating the price in real time. This might even be better than what you're getting on Dex Screener. I've heard that there are price delays on Dex Screener, so this probably is better than what this is showing. But look, it pretty much matches. So there's 5 zeros for this is the price per token in Sol. So it's in the ballpark. So that pretty much is in the ballpark of that. All right, so now we have something working. So now this is getting the price in real time. That is a lot of progress. So congratulations if you made it to the end. I will see you on the next one.